Hello, everyone, and welcome to our Digital Futures Saturday tutorial series. And today we're gonna introduce you our tutorial session on Introduction to ML Agents in Unity and Virtual Environments. My name is Reem, and on the behalf of the Digital Futures team, I would like to welcome Ahmed Elmaraghy for joining us all the way from ATH Zurich. It's my pleasure to introduce Ahmed today. Ahmed is an architect and a researcher. He has worked as an architect and a teaching assistant at Politecnico di Milano, where he taught the adaptive facade studio. Ahmed is also works with artificial intelligence as his main focus in research. He has currently graduated from Politecnico di Milano, where he completed his master's on the potentials of reinforcement learning and integrating that with advanced technologies and AI. He is currently pursuing his master's in advanced studies at ETH Zurich, where he's focusing on digital fabrication and architecture. So today we're gonna have a session where you're gonna get an overview of deep reinforcement learning and its principles. You'll also get to learn the use of ML agents in Unity and how to challenge and solve problems. And finally, you'll get a guided overview and a walk through the installation process of the softwares and an explanations of how virtual environments work in Anaconda. So I'd like to welcome Ahmed today, and I'd like to just give a small announcement for those who are watching on YouTube live stream, or if you're participating with us here in Zoom, just make sure to put all your questions in our chats, and we'll address them all towards our Q&A session at the end. So I'm gonna leave the floor to Ahmed, and I'd like to welcome him again joining us today.
Thanks a lot, Reem. It's my pleasure to be here with you, and it's always a pleasure to be within, let's say, the Digital Futures environment and let's say enriching experience. Always, it's been some time, and I've started even with taking a lot of interesting workshops and listening to a lot of interesting talks, and yeah, I mean, I would be so grateful to pay back a small amount of what I've learned through this platform. So it's my pleasure to be here. Thank you. So if you don't mind, I would share my screen.
Yes, please go ahead.
So hello everyone, and I'm Ahmed Elmaraghy, and today we'll be having, let's say, an introductory tutorial slash quick overview of reinforcement learning as part of the machine learning, let's say, environment or machine learning divisions. And the reason to, let's say, to start with some sort of theory is to get people familiar with what is reinforcement learning in case you're not familiar with, and also to give some examples of how this thing can have a potential in architecture and in our field in general. So I'll start with a quick introduction, and we go through very basics of reinforcement learning, how it works, and some applications in our industry, and explaining something called the Markov decision process. So how you can, let's say, convey your problem into something that can be solved through reinforcement learning. And based on this, we will explain some, let's say, installation process of Anaconda and the virtual environments, which will help us to install the ML agents, which is an easy interface to get familiar quickly with reinforcement learning in Unity, and will help you further develop your project, whether on a, let's say, in a simple way, or even if you want to go further and work on the Python API, would be also provides very useful tools. And then eventually we'll give, hopefully time will allow us to give smart examples of how you could implement this in Unity. So first of all, a quick introduction about me. So I don't like to spend too much time on this, but in any case, I'm a bit old now, but yeah, I started in Care University and then as construction management, and then went to Netherlands for my part of my master's, and then had a master's in design management in Cairo, and then master's in Politecnico di Milano. Been working in Milano for around 3 years as architect, and just came here last September in ETH to pursue Master of Advanced Studies in Digital Fabrication. So, I mean, I've 2014, you witnessed some of the boom of Grasshopper and Dynamo at that time as well. And these things were pretty interesting for me and how to optimize problems. And then when I got, let's say, exposed, also partly thanks to DigitalFUTURES, to machine learning, to neural networks, supervised and unsupervised GANs, and so on, and how they can be deployed to solve and to elevate the quality of the solution that we provide in a quite sophisticated environment like the AEC problems. And yeah, quick also introduction. I've participated in several things in DigitalFUTURES. One of it was a workshop in 2021 run by George Guida, Runja Tian, and Dongjun Kim. And yeah, they were focusing on GANs and focusing on the, let's say, style GAN and how to produce latent walks and so on. So it's a pretty also interesting topic. And yeah, that was one of the products that we have as an output. It was like an abstract Gothic walk that was deployed. And yeah, I will not spend too much time here. And also last July, along with my professor, Pier Paolo Ruttico, and also my colleague Carlo Beltracchi, Index Lab, we had our workshop through DigitalFUTURES platform, which was the interesting in it. It was exposing three different topics and how they could be integrated together. So it was robotics, metaverse, and AI. And yeah, basically I was into the AI part. So it was really nice also to learn from both guys and in the different aspects they have knowledge in. So mainly we can divide the tutorial into, as I said, an introduction, small lecture, I would say, about reinforcement learning and how it's generally developed and used in our modern world now, and potentials in our industry. And then the second part would be more or less how to install the tools that would help us deploy something like this in by ourselves. So reinforcement learning, as you know, machine learning is a big topic, and there's always this how to divide the machine learning topics. Mainly, there are three. Sometimes they make it four. Let's say big branches, which is supervised learning, unsupervised, and reinforcement learning. And then there is the semi-supervised, which is sometimes considered as a fourth branch. Today, we'll be focusing on reinforcement learning, which I found it super interesting because being young, I was always like so into strategic games or like playing online games and so on. Yeah, at that time it was different than nowadays, but the idea is that you, let's say, incentivize or give incentives to your player, to the agent, to do something and let it figure it out how the best possible way to do it is really an interesting topic. And it could be deployed in several ways depending on the problem we have. So to simplify the concept of reinforcement learning, you can see here a dog. And normally when you train the dog, you cannot train it without giving a reward or a penalty. And in here is the treat. So when the dog, let's say, more or less understands what you mean, what you intend by your word or your, let's say, hand movement or something, and it does it correctly, you give it a reward. So basically, also our minds work in this way. If you the minds try to connect this reward with the action that you have done. So by this way, you start learning, and for animals, for us, and for agents as well, like for computers. So given this idea, one of the things that was like, let's say, made a big boom in recent years was AlphaGo. So AlphaGo is, let's say, a much more complicated game than chess. So it's a turn-based game, and it's really famous in the region in Korea and so on. And DeepMind at the time was managed to, let's say, develop an algorithm based on reinforcement learning that was able to learn from a lot of games, and then was able to win. I guess it was 4-1. So it was a game of 5 with the, let's say, #1 ranked Go game player, professional player in there. And as you can see, like his gesture was caught, and he did this gesture because at the beginning he was thinking that the machine has made a mistake, so the agent has made a mistake or hasn't made a wrong move. But then eventually he realized that it made a move that it was never done before. So you can see here this sort of inspiration that we can get from machines. So exploring perhaps routes or directions that by ourselves it would be difficult to explore, or would take a longer time. And yeah, this guy was a part of the DeepMind team, and he was just getting the, let's say, the order or like the step from the computer, and then just putting it on the actual table. So as you can see, AlphaGo was the first computer program to defeat a professional human Go player, the first to defeat a Go world champion, and is arguably the strongest Go player in history. So given this, it's a challenging game, and here you can see the number of states, of possible states that can possibly exist in this game. So they're approaching a really big number, and here we're talking about turn-based games. So it's not even a real-time strategy games. So it's something that that even is much more complicated, and yeah, states would reach almost infinity. So you can see how complexity get exponentially bigger and bigger by jumping to real problems. So just a quick notification, or like to stress on it. State, what is meant by state is if you take a picture of this, let's say of this form, and is a picture of where all the let's say the elements are put in a certain place. So this is what is called the state in this aspect, for example. And then the second, let's say, development that was really interesting in this field was also by DeepMind. It was AlphaStar. So AlphaStar was also, let's say, a mix of part of reinforcement learning is also imitation learning. So imitation learning is that you learn from the games of good players, let's say, and then out of this experience, you start from there to develop your own strategies and so on. So yeah, this kind of incremental learning is an essential process when it comes to a really complex situations like in here, like in StarCraft. And reaching this type of complexity and being able to defeat, let's say, world champions on Blizzard, on the platform of online platform of StarCraft, is giving us a great potential on the possibilities that we can use such algorithms in solving problems, perhaps in our industry. So someone would wonder why ChatGPT would be on the list here, but actually part of the, let's say, the improvement of ChatGPT was carried out through reinforcement learning. So apart from the, let's say, the supervised learning method and I will not get into details in there. But then to improve the quality of the output of ChatGPT, there were like, let's say, human interference in here. So getting feedback from the humans on the quality of the text or whatever that is produced. And based on this numbering system, let's say there was a reward system given to the agent, on which it's given more rewards when the human is satisfied with the answer, and less rewards or penalties when the human is not completely satisfied. And in that case, they used also the PPO algorithm, I believe, proximal policy optimization. We can talk a bit also on some of these algorithms. And yeah, they use this kind of algorithms to carry out this learning process. So a quick overview of applications. So reinforcement learning in our industry is relatively new, I would say. There has been quite remarkable number of papers and of projects that has been deploying RL recently, and I guess it's a really good initiative or good start. I think in the future also, the more it's easier for us to enable the use of such algorithms, the more it will be used better and better. So imagine like if we didn't have Grasshopper in the past, it would be harder to deploy visual programming or like computational geometry or design. And the same would go for machine learning in general. So I would not get also too much details, but for sure, if any of you wants to get more examples, I have plenty by really reputable researchers and everything. So if you like, I would share this later to you. I would just give a visual video example that was related to construction, so assembly more. It was done at ETH, finished 3 years ago. And here it was built on also some sort of imitation learning, that the user is using a simulation interface in which it's trying to teach let's say the robot how to join these two timber bars. And then through learning, as you can see through progress, the agent is trying to imitate or like learn from the user and develop its own methods. And eventually, let's say the big scale or the big benefit, if you properly deploy reinforcement learning in a good way, is that you can generalize problems. So you might face problems that has never been encountered before, and yet the agent would try to generate a proper solution. As you can see here, it's another positive thing is that you can do all of this in a simulated environment. So eventually you wouldn't need any, let's say, loss of material or loss of resources just online. And the more you have accurate simulation of the material of the situation, it would be easier in the real life to deploy such an experiment. So sensors and so on can be retrieved information from, and given these numbers, the robot would be familiar with the actual environment, similar as the simulated environment. And as you can see here, different angles were reached eventually. And yeah, I'll just move to the second one. Here's a quick example of what I was working on during my thesis in Milano, along with my supervisors. And it was the idea was to make, let's say, a game, but game related to our industry, in which the final goal is to build a pavilion of bricks, and you have a certain kind of criteria, design criteria and construction criteria that you need to meet. And based on each of these criteria, you get the rewards or penalties. And eventually you end up with building if you end up successfully, so you will find an agent who is capable of building this thing till the end. So here, this was the, let's say, the human part. So you get you provide this game to the humans or to the architects just to get their feedback and say, okay, this is what we want, or these are the kind of reward system that we would accept. And as you can see here that let's say these are positive rewards because we're saying one of the incentives given to the agent is that if you try to build, insert the bricks next to each other, you get a positive continuous rewards because you're, let's say, reducing the energy instead of building one brick here, one brick there. And then you need to place a proper door in the right direction according to the wind that you have here, wind direction, prevailing wind, sorry, for the windows. And here, as you can see, if you pile bricks over each other and fall, you fail the game. So practically, you're giving this problem to the agent, and it's the same. It has to. The only thing is that it has to learn from zero, based on just on the rewards that you give to it. And yeah, these were, for example, kind of rewards that we experimented with, like continuous brick, design gap, high brick penalty. So if you build a lot of high bricks without finishing the current, let's say, lower levels, achievement of cross ventilation, stack ventilation, counter bricks. So yeah, these were more or less several rewards that we were trying to check. And yeah, eventually, as you can see, this is how the agent was failing a lot. So it's not, so of course, this is the speed is increased just for learning, as well as the physics, so it can cope with the actual environment. And as you can see, there were a lot of failures in the beginning, and it was hard for the agent to learn. And this was like a final video after the agents were able to learn what how they can achieve the whole building, while maintaining all the checks that we wanted, including design and construction-wise. I will also skip here quickly. Here you can see, the thing is that there was, like, we divided the tasks or like the building into phases to facilitate the learning of the agents, to make it easier for them. And here it was in the beginning, it was, let's say, as you can see, a lot of failures. Bricks were falling down. And then, as you can see here, let's say the agents learned that it's better to follow this incremental approach, even without telling it directly. And even in cases of sparse environment, so even without giving it any reward, but in the end, it was managing to realize that for this situation, this is the most probable approach to succeed. And as you can see here, it's starting to build the whole structure. And then eventually, that was the last phase, which is the dome phase. It was the most critical part because you have the inclination, and it took a longer time to learn. And eventually, we discovered that there was a problem, that it reached the final level, but there were like some gaps in between, as you will see now. So it was, we tried to introduce a penalty that if you create any sort of gap, it would yeah, penalize you. And in this way, yeah, as you can see here, there were a lot of gaps. So we just introduced a negative penalty for the gaps, and then it was able to build the building properly without creating the gaps. So that was the final conclusion, more or less. And training was not an easy part at all. It took a lot of time, and the challenge is always to decide what are the parameters, or what are the things, because you are the eyes for the agent. So you need to decide what the agent will see out of this environment. What are the parameters that the agent should should witness, and based on it, take a decision. So this is one of the most critical parts in this process. So given this quick review, we'll just explain one last thing, theoretical thing, which is Markov decision process. So it's more or less the conveyor of any problem into a problem that can be solved using RL. So it's just categorizing the problem that we have into several aspects. So for example, if we have, in order to formulate a problem, we need to define what is the environment that the agent is active in. So the boundaries and so on, not necessarily boundaries, but like not necessarily physical boundaries, but what is included in the environment that the agent should be aware of. And then we need to, each time before the agent taking an action, it should observe a state. So observe some things in this environment and report it to its brain. So in here you have the state, which we said briefly in the Go game. So you get a, like as if you take a screenshot of the environment, put it into the agent and solve it with one of the, or try to increase your, it's called optimized policy. So the policy that the agent would take when it encounters a problem. And based on this policy, and based on the feedback, so it based on this policy, it takes an action. And then once it takes an action, the environment is changing. And based on this change, probably at some point, the agent takes a reward. So the critical thing is always, you never get a reward, you never get instant reward, but perhaps after a few steps or 100 steps, or even at the end of the game. So this is one of the challenges that RL algorithms are, let's say, competing to solve. So how to link the reward with the state, or with the sequence of steps that you have done leading to this reward. So yeah, eventually, as simple as this, the goal of any RL, reinforcement learning algorithm, is to maximize cumulative reward. And cumulative reward is, let's say, if you are at state X, what is the expected most, let's say, the most amount of rewards that you can get in order to reach the final episode, or the final end of the game. And of course, we, as an agent, is not aware of all the possibilities, so it starts making expectations or probabilities, because it's impossible to discover or to go through all the possible solutions. So it's tried to be smart and to expect what will happen without actually exploring all the possibilities. And yeah, with this, we end, let's say, the theoretical part, or the theoretical first part. If anyone has a quick question now, otherwise we can proceed.
Yeah, looks like we're good. I did see some comments in the chat. The documentary where narrator discussed the idea of a beauty move made by a machine. Someone did kind of put a comment, but we're good otherwise. We can go ahead.
Okay, perfect. So this was a quick, let's say, theoretical introduction, and what we will do now is to use this let's say tutorial later, whenever you want to install ML agents, because it took a lot of time for me to figure out the easy way. Now it's getting even way easier. So what we will do now is that we will also discuss what is Anaconda and how to use virtual environments, and then how to use the virtual environment to create one for ML agents in Unity, how to install ML agents in Unity platform, and how to use them eventually. So first of all, it would require that you have a Unity version. So it's almost the Unity version depends on what version of ML agents that you want to use. I don't know which screen I'm sharing now. If you can just just sharing you. Okay.
You're on the presentation screen.
Okay.
Yeah.
I will. Okay, let me continue in the presentation for a moment and then go back. So Anaconda is more or less, let's say, an enabler in for Python and R to develop this kind of virtual environment. What is meant by virtual environment in simple words is that you normally have, let's say, you go through different projects, and each project requires a certain type of packages. So maybe you use Python 3.2 for some packages, Python 3.3 for another package for another project. So this one is creating a virtual folder for you to keep everything that are consistent together. Because a problem you always face when you install packages working on Python is that they might be incompatible. So maybe PyTorch is not working with another library or whatever. So using virtual environment, you create this distinction and keep the packages together more or less. So if anybody wants also to follow, I will be, let's say, slow. I will not be that fast. And the first thing that we could do is that we can install Anaconda. So an option to check is, let me share the screen. So sometimes also ML agents provide an explanation of how you can install Anaconda, but it's really easy. You just go to Anaconda Python, and then you can just press download. And once you download, you can get the version that you want. So here's Python 3.9, but you can also use another version later. So you start downloading, and then after you download, it will end something like this. So let me just re-download it again. So as if we're downloading now, let me open for you Anaconda. So normally you can access Anaconda two ways, through the prompt, which for you who's not familiar with this is like the DOS in old times. So it's just an easier way sometimes when you're coding to reach or to do what you want to do. And for people who are not familiar, but I would recommend this way. Let's say you have the actual style of Windows, so you have the platform
Ahmed,
of
just a second, sorry. We still see your Google Chrome where
okay,
the
so
Anaconda, yeah. And also there's a quick question in the chat. What about Google Colab? Can Unity and Colab interact with each other? This is from Naseem.
okay, so what you could do, which is also like a further question, I will answer this in the end, but it depends what you want to do. But if you're talking about RL development, ML agents can provide you this kind of API Python that you can, let's say, use Colab to build your own algorithm and then use it through ML agents application in Unity to deploy what's happening in the learning process and get this feedback backwards. So two-side feedback. So it's possible, but it's, let's say, a more advanced way, which is also, I can send you the link is here when downloading ML agents. So enabling the API Python process, more or less. So I will just open Unity right now, open Anaconda now. Just a second. So I guess you can now see the window. So this is Anaconda Navigator. And if you go through the environments, so these are, let's say, the projects that I have on this computer. And for each project, like this is the base, but like this, let's say one project, you would, once you click on it, it will provide you with all the libraries and the versions that they are used in this virtual environment. And this is really important because let's say if you want to install a newer version of Unity, of ML agents, it requires a certain version of Unity, it requires a certain version of Python and so on. So you wouldn't like to do this in the base, like in without creating this environment, because otherwise everything will get, so let's say if you update Python, it will be updated on everything if you do not create virtual environments. So if ML agents is still using, let's say, Python 3.8 point something, and then you upgrade it to 3.9 on all platform, on all your computer, you will have a problem. So what you need is to customize. So use the version that is compatible with what you are planning to do, and without affecting any other. So as long as you are activating this environment, it's as if it's like online, as if you turned on your computer with only this environment. And then you can turn off this environment and whatever dependencies it's working on, and then open another project, let's say in Grasshopper, that is using another environment in Anaconda. Grasshopper or Unity or whatever, like whatever dependencies you are using. And here, as you can see, like there are 2 or 3 different versions of ML agents, depending on yeah, the Unity and the ML agents version that we are using. So this is just an introduction of how this environment looks like. So for sure, you can here, as you can see, you can create, you can clone, you can import, so you can do everything in this like user interface. But normally what we used to do is to open the command prompt or like the Anaconda prompt and start doing this thing from scratch in there. So I will just close this one now. Yeah, and let me share my screen. I will just not to maybe let me close it and open again, open a new tab on PowerShell. Let's close this one. So here is, let's say, the prompt that would appear, and here when you see base, this means that we are on the base environment, that there is not any environment called or activated. And also through this way you can use cloning or downloading something online, whatever, but bear in mind that it will be this directory is where it will be downloaded. So you need also to adjust this directory based on the place that you want to download. So moving from this, I will show you the Unity. So as you can see here, this is, let's say, the installation guide for ML agents release 20. So here it's, as you can see, to install ML agents, you need to install Unity. This is as a first step. So it's clearly indicating which version of Unity that you would use. So for those of you who wants to try now, you can go with installing Unity 2021.3. And what happens is that you need to go first. Let's open a new one. And then let's say you call Unity. And then what happens is that what you download, first of all, if you're a student, you can just select the student one, which is free. Also, the personal one is free, but it has, let's say, less resources, but it will not affect you that much as long as you're not working for producing commercial applications or something. So you can go for any of them. The student one requires a license, so you just need to sign up with your student ID, student email, and so on. And once you sign up, you will end up with installing the Unity Hub. So what happens that you do not install directly a certain version, but you install Unity Hub, which is like hub for all the versions of Unity that you have. And if you go to installs, if someone is installing for the first time, you will not find anything here. And you will just click on add. And then you would try to select which version that you want. So if we go back to in here, it's asking for 2021.3. So if you have here because I have it, of course, but let's say if you want, you can, let's say, use a newer version, it will not be a problem. But I would always recommend to avoid any pre-releases because it's just more on the debugging side, it's a bit risky. So you would either go for an LTS version, which is like, let's say, already checked and working version, or a version that is necessitated, let's say, clearly indicated through ML agents to be installed. So in that case, I installed, let's say, Unity 2021.3.15. And in case you cannot find the version that you want, you can just go to the download archive. And then in this case, you will find which year, so Unity 2021, let's say, and then you can download through Unity Hub. So it will open Unity Hub, and then it will tell you what do you want to download. So here, normally you would go for Visual Studio, or if you want Visual Studio Code, there could be another way and documentation. The rest is more or less regarding what kind of build you are going to do. So as long as you're just not producing an application in the end, you don't need to download anything for now, but then otherwise you can download something for build support of Windows, for Mac, for Linux, for iOS, Android, and so on. So basically documentation and Visual Studio would be enough. You click on install and then you start installing. Normally it takes time based, of course, on the internet speed and so on. And then afterwards, it will be present here as one of the versions that you have of Unity. Okay. Any questions so far? Okay.
I think we're good. Ahmed, do we need to drop any links in the chat or?
I can send, yes.
Maybe the Unity link or.
Yeah, sure. I can send you the link of Unity as well if you want. Here. Okay, and again, do not feel like obliged to download everything and work now, because it's better just to follow now and see all the steps, and then you will already have the tutorial recorded. So do not worry at all. This is not, let's say, the objective. but to tell you as much as possible the steps that you need to follow. But of course, if anyone is following and has any debugging issue or a problem, just drop a message and let me know. So after you finish downloading, here, what is asking afterwards is to install Python 3.8.13 or higher. Okay, so as we said earlier, what we want to do is to use the versions that are necessitated or required by this version of ML agents. So now again, we're using ML agents version release 20. If we go here, let me show you. So here's the website for ML agents. It's a bit problematic, like they have several websites and some of them are obsolete. So I mean, it's a bit hard to follow. So that's why I'm like specifying a certain release and explaining the steps of how you can download it. And then later on, you can, if there is a newer release or something, you can do the same. I can send you also this one. So here we're seeing release 20. So it's saying that whenever, so on GitHub, you always have the main branch and the other branches, let's say. So mainly the main is what they use to update always the application. So it's not advised at all to download an unstable version, because we already have a lot of problems with the normal version. So I mean, please stay away of any unstable one. You can just see the let's say the newest already supported release, which is here, release 20. I normally use or using 19 and 18, but then we can try 20 today just to see how it's working. And then you can check on the source. And this is, let's say, the, yeah, as you can see, it comes back again to this part. You can download it. So there are two ways of downloading this one. Either you download it in this way, so the normal way, clicking and downloading, or if you have GitHub, you can download through GitHub by cloning, or you can also use it in this way, which I will show you now. So here you can use the git clone inside of Anaconda or VS Code. So whatever you like, I'll just show one way, but anybody who's used on or on another way, it's clearly possible. So we go to the Anaconda prompt, which is like our Windows, but in a DOS way. Here, if you say git clone, so it's asking you to download. Clone means making like a replica of this branch. So we're saying, please go to the branch that's called release 20 on this website and download it in this position. And in this position, we are assuming that we are in this place. So users, Ahmed, in this place. If you want to go to a different place, if you click on this way, you go back. If you click CD and then you type, these are all the folders that are there in this directory. And then you can also, yeah, if you're just satisfied with this place, you can create it here. You can also create another folder. I don't remember what is the direct, like the order to create a folder. MK, I guess. Let's see. Yeah. So here is MK directory. So we go here. We say MK directory, and then let's say digital futures. So now if you click on CD, now you can access this new folder that you created. So once you are satisfied with the place you want to download or you want to clone, you select this line of code, which I can also copy it here. So this one. And then you go in here and then you start downloading. So as you can see, it's just you give the command prompt, the direction, the website on which to download the thing. And to be specific, we are clearly specifying that we want branch release 20, because otherwise it will go directly to the main and it will install the unstable version. Okay. So as it's installing, we can show how it looks like in the end. So we are working with release 20. It was installed. And then as you can see, it's made of folders. If you check the same branch online, it will be having the same folder exactly on GitHub. So you're just cloning this file. And of course, you'll not be allowed to make any modifications if you clone the repository on VS Code or whatever, because it's not allowed, of course. But yeah, it is allowed for you to pull any updates. So once you have it here, we can just, if you download it, you will have in the documents the file that I'm actually showing you now, which is, they have a file for explaining how to install Anaconda, which is pretty easy. So you don't need to have any, you don't need to open this one, but I can show it to you as well. So it's just saying how to open it and what to use and so on, and then it's just opened. And here is just explaining how you can create environment inside of the command prompt, which we'll go to it right now. So another file that you will have in here in the docs, sorry, is the installation itself, which is the one that we were checking, which is this one. So it's what do we have to install in order to have the files. So again, we first started with Unity. We downloaded the version of Unity that we want, and then we cloned the or downloaded the files and folders for version release 20 of ML agents. And this release 20 has all, let's say, the files that will be updated on the side of Unity, inside of the application of Unity itself. Now, what we need to do is to download all the packages or the prerequisites of ML agents, of PyTorch, of whatever that are used within this application. So to do so, this will go to this back later. What we need to do is to create a virtual environment in Anaconda in order to install all of these requirements. How we can do so, as you can see here. So we go back to our command prompt. Yeah, it's still downloading. We can finish, we can let it finish, and then we can continue. Meanwhile, if anybody has a question, please let me know. Okay. Now that we downloaded the release 20 folder, also inside of the folder itself, you will find the environments or the projects that you can use it. Like they give you sample projects to play with and to see the code and to try even to train them by yourselves. And we will get to this point as well later on. So while you are on the base, now we need to create a new environment. So as you can see here, in order to create a new environment, you use, sorry, Anaconda. Me. So you will use this line of code. Let me send to you, but we need to make sure of one thing, which is here. So as you remember, we need to be specific with the version. So we need Python 3.8.13. So we just need to make sure that we are typing the right version of Python. So here, so we take this one, and then we go to our command prompt. Now, since it's giving us this cursor, it means that it has finished what it was doing and ready to take any commands. So what we say is that we want to Conda, we're asking Conda to create a virtual environment, a new one, which is called ML agents. So let's say we need to check that this name is not included in your environment. You can just use another name, let's say. Whatever name you want to use. And then in Python, as you remember, we wanted to use Python 3.8.13. And then once we click in enter. Now it's starting to download all the dependencies or the libraries that are needed. And we click yes. As you can see here, the location of the environment is in this place. It will not matter that much for you because you do not access the actual folder for the environments. It's just the place where everything is installed. So you start downloading everything. So I will share this line of code with you as well. So I will just so if you type the name of the environment as ML agents, probably if you haven't installed ML agents before, so this name will not be taken, but it's just a name for a folder. Consider it in this way. So whatever the name is, the most important thing is that you remember it, because this is how you will code the environment to open. And here, as you can see, if you are with me and installing release 20, you will have Python. You need to necessitate that I want to install Python 3.8.13. And then now, after it finishes, it tells you this one, which in my opinion, what you should do is to take it into, let's say, a notepad or something, as I do here, and then take the name. So here, normally when you activate an environment, you say conda activate, and then it's asking for ML agents activate this kind of environment, which we named it in this way. So I will just keep this one here. And then once you finish everything you're doing and you want to close this virtual environment, you just say Anaconda deactivate. So now, as you can see, we are still on the base. So we are not opening any environment yet. So what we need to do is to call this line and paste it here, and then click enter. Nothing will change, but this line in the beginning is telling you that, okay, I'm now opening or accessing all the packages, the Python packages that are included or installed in this repository. And if you want to install anything now, I will install it in here. So it's not on the base, it will be installed in here. So we need to install the ML agents package. So as you can see here, they no longer use TensorFlow. That's why if you follow in one of the things, it will just not be relevant. So here, let me go through this one. So what we need to install is first install PyTorch, and then it's giving it also the version that we want to install. So PyTorch is same as TensorFlow. It's a machine learning package. So the good thing about ML agents is that it provides you two options. One is to develop everything, so develop the environment, and how it would work. But then when you select an algorithm, you don't need to write the algorithm from scratch. You just say that, okay, I will use proximal policy optimization, and it just gives you a file of hyperparameters that you need to adjust. So it's actually, they wrote on the Python side the whole algorithm, and it's just giving you access to the parameters in a YAML file, which we will see later. The second option, which someone was asking for, let's say I want to develop the whole code or a new code or whatever, RL code on Colab, and then I wanted to use it in Unity. So in that case, you just enable the API, which you can see here for development. So you install it in this way, and then you can access all the, let's say, the functions inside of ML agents on the let's say the Python side, like the environment step, environment whatever, so how to step the environment and so on, and deploy your algorithm inside of it. So what we'll do now is the traditional installation. So we just need to install PyTorch now. So now it follows the link and it starts to download. So sometimes some packages take some. As you can see, it's now currently installing. And then after installing, so let me also send you this. But also you can find it in the folder of release 20. While it's downloading, let me just explain a quick thing. So we have, let's say, more or less two distinct things that we do in parallel. So one on the Unity side and one on the, let's say, development side. So in Unity, we need, of course, to download the application that we have. And then plus we do like as if in Grasshopper, if probably familiar a lot with Grasshopper. So you have the Grasshopper installed, which is, let's say, Unity now, and then you want to install a library or a package. So you need to install the package of ML agents. Sorry for the nice writing that I have. But then on the other side, on the development side, you need to install, let's say, the packages that that performs the machine learning work or the reinforcement learning work. So once you set up all your environment here, giving it, let's say, giving outside what will be the observations, what will be the rewards and so on, and then you set up everything here. You say, okay, I have now the environment, please connect to your, let's say, solver to make it simple, and use what it have inside, like the black box that you have to start learning this environment. And then after it learns, this thing produces something called .onnx file, which is considered as the brain. So this is, let's say, the brain that you have. Once you have this brain, once you're, let's say, satisfied with the results of the training, you just deploy this brain here, put it as like a file, which we will see, and then use this brain to take the actions directly. So you no longer need to train anything. This is, you finish training, and then normally after you finish training, you need to just deploy the thing inside of the environment. So this is more or less what happens here. And this is what we will see in the next, let's say, half an hour to 45 minutes. Once you have everything installed, you would go here and then install the package for ML agents. So the reason we installed PyTorch, because ML agents uses PyTorch to in its own algorithms that it has written already. Go here, install ML agents. Let me send you this file as well, this link, sorry. The installation is a bit, let's say, hard. But then once everything is working, you feel like it's a big achievement. And then you can directly do whatever you want, like inside of the Unity environment. So once this one finishes installation, so we would have finished, let's say, the left part, so the brain part and all the dependencies. And now we go to Unity and open it and see what's going on in there. So for anyone who was asking how to the Colab thing, so here now for advanced local installation, you need, if you intend to make modifications to ML agents or ML agents environment, you should install the packages from clone repository rather than PyPy. To do this, you need to install ML agents and ML agents environment separately. This will take more time. So if anybody is specifically interested in this, we can talk about it later on. And yeah, eventually, not at all. Yeah, so eventually this is almost the end on our side here. So let me save time and go to Unity. So we'll pretend that okay, it has finished. So one more thing to make sure that it has worked properly is to where was it? So say if you install this correctly, you should be able to run ML agents learn help. So it gives you all the help commands that you need to that you can access. So let's go here, type this one. So as you can see, it gives you all this like 2 dashes, like what you can write here to get this thing, like to get what's written here. So here, if you use resume, we will see this one, how to use resume, how to use force, run IDs, like a certain ID for the run that you're having. Initialize from is to, if you have a previous run and you don't want to lose it. So let's say your brain or like your agent has learned 10%, but then something happens and then you want to change parameters at a certain point and start from this file, but in a new file. So you can say initialize from this old file. And there are a lot of other things that you can check by yourself. Touch devices, what kind of device you want to use, CPU or the CUDA, which is like let's say if you have the RTX video, I don't remember the name, video card. So it's the Vega card that you have installed. So if you have a powerful one, please use it as the one running on for teaching the agents. So we finished here. We can minimize this one. Let's open this file. And here I have this project, but I will show you how to include it in the Unity environment. So what you do is that you say, okay, I want to add a project, because actually ML Agents is providing you with an example project. And you go here in ML Agents release 20, you find a folder named project, and then you select this folder. Once you select it, it will appear here with the proper version. So if it's installed, let's say if it's 2021.3.1 and you don't have 0.1 but you have 0.50, it will just ask you to update, and you will just update it and then click on it. Okay, it's already open. So, and then you have this file open. So normally you don't have any scenes here, you just click on whatever scenes you have. So we can just go check all the scenes or all the examples that Unity is providing. So here, to make it easier for you, which was for me really helpful in the beginning of this journey with ML agents, is how to write the code, how to write the proper code for the agents, especially on the C# side, on the Unity side. And these, let's say, already working environments are really helpful for this reason. So it gives you like, what is the environment, what was the goal, what was the reward, what was the observations that you need to provide to the agent, and what is, let's say, the actions, and then what was the benchmark reward if you want to retrain it with changing any of the parameters of the algorithm. So you have either two ways. Maybe you want to develop a new algorithm and you want to check if it's more effective. So you can just train it on this environment to start with and then see how it's working instead of making a new environment, which also takes time. Or you have an actual problem, you made it in Unity, and then you want to help with how to transform it into something like as we said, the Markov decision process environment through the classes of ML agents, which we'll see it now. So you use these kind of environments to check its code and copy some of it. Or you can ask ChatGPT and then it will help you with this stuff as well. So yeah, bear in mind, not everything's still 100% working on it. So you need just to be aware of the where would be the problems that you have. So for example, we can check this file. So this is a game. So all of these, of course, are games. They call it environment. And here, what normally happens is that you want to reduce the speed of the training as much as possible. How is this achieved? By one of the things to achieve it is to create multiple instances of the environment. So consider as if only this part, let's say, is an environment by itself. So the agent is seeing actually only this one as one environment, but is getting, let's say, observations from these similar environments. One good thing is that if you, let's say, if you have, and of course, Unity ML agents allows parallel training. This is called parallel training because it helps in fast training from one side. And at the same time, if the problem gets more complex, it allows to get the agent exposed to different scenarios. So here, okay, there might be, the scenarios are not that obvious, but if you have, let's say, complicated scenarios, maybe it would be subjected or like it would be confronted only by this agent, but this agent will never see it. So in that case, you have more chance to generalize your solution or to let the agent discover more problems during the training, which you actually need. So if you can check this file, which I will send to you as well. This one is really nice as an like instantiation of how you can set up what is the goal, what is the rewards, and so on. And we will go through this now. I will send you the file. Okay. So we have here, for instance, this environment. There is grid world, there is push block. So please feel free to, this one I like so much. I don't know why, but this one is actually like you're controlling with the, let's say, the joints of this thing to reach to the goal or to the box. So let's, for example, check what are they saying here. So a crawler. The setup is a creature with 4 arms and 4 forearms. The agents must move its body towards the goal direction without falling. So this is the goal of the environment. So the environment will, once it reaches this goal, it gets maybe the final reward. And then the agent is, the environment contains 10 agents with the same behavior parameters. So you have 10 agents working in parallel on separate environments. And then the reward function, which is really important. So how the agent would learn is by getting a reward. So the reward function is now geometric, meaning the reward, each step is a product of all the rewards instead of the sum. This helps the agent to try to maximize all rewards instead of the easiest ones. Body velocity matches goal velocity, normalized between 0 and 1. Head direction, alignment with goal direction, normalized between 0 and 1. So here it's like more or less getting, let's say, a feedback on how the let's say the sum of the joints, the effect of the joints, moves this robot or whatever from one point to the other. And based on the product of all of these joints, if it's going in the positive direction or if it's, let's say, working properly, it will maximize the reward. If they are going in a different way and it's like stumbling or anything, so it will give it a negative penalty. So, okay, how the agent is looking at this environment, you have something called vector observation, which is 172 variables corresponding to position, rotation, velocity, and angular velocity of each limb. So this is what the agent receives from the environment as the observation. And the actions here is like 20 continuous actions corresponding to the joins. So whatever the joins we have here, the agent gives an indication of what will be the value of the joint in each action. And there is no visual observation, means that there is no camera that's looking or getting any feedback and putting it to the brain of the agent. So this might be a bit complex for now. So let's go to a fairly easier one, which is the 3D ball. So the goal is as simple as this one will be, let's see how it looks like in here. Let's try to play it. So as you can see, this is already a trained file. So you have everything trained. You have the agents already trying to, they are pretty successful. So as you can see, the ball is not falling from all of them. So this is mainly after training. If you want to train them from scratch, we will show this also in a different example. And let's go through what's this environment and how it can be deployed in ML agents. So let's go again to the website and see. So first of all, the goal is to keep the ball balanced. So there is a distinction between something called episodic tasks, and then we have the continuous task. So this is a continuous task. You will not end, meaning that if you keep successfully, you will always keep the ball inside. It will end only if you fail. So this means that it's better to give the agent the reward instantly based on what it's doing. So the reward is +1 for every step the ball remains on its head. So as long as it's remaining within a certain level, it takes an action, and then if the action keeps the ball inside, then it takes a reward. If it's not, then it takes, if it falls, it takes a penalty, and then it restarts again. So here, the observation, so what the agent sees from this environment is 8 variables corresponding to the rotation of the agent cube, position, and velocity of the ball. There are different versions of this game, so we will check one of them. These are just some properties to scale the balls or like to play with gravity and then restart training. So it's really a good exercise for you to play with these things and then retrain the agent from scratch. So if we go back here, as you can see, in Unity, you have how many? You have 12 instances. So you have as if you have 12 environments in the same folder or in the same scene. And then each one is assigned an agent. So makes sense that the agent is the cube, because this is like the brain is controlling the cube, so the ball does not fall. And if you check here, these are the files that are affected by ML agents, like the file that are adjusted by ML agents. Just one thing I forgot to tell you, but once you download it in this way, it will directly be implemented most of the time. Is that if you go here to package manager, here you need to see that you have the ML agents installed. Otherwise, if it's not installed, you can just check ML agents and then install the certain version that you want. Otherwise, you can install it directly from the directory. So you actually remember the first folder that we installed. So you can add package from this and then go to the, let's say, the folder that you installed in. This one. So you have ML agents, and then you can install the file. You can check for the JSON file, and then you can download it. You can install it in this way instead of downloading from the online platform. just to make sure. This will help you that you have exactly the version that you're looking for. Otherwise, it will tell you what is the currently installed version here and what do you want, what would you prefer to install instead. But currently is the most recent version installed on this file. To give a quick introduction, so what are the, so if you're not familiar with Unity, normally this is called a game object. So any object is in the scene. So this is the scene. So this is everything you have inside the scene of Unity. And then these are, let's say, the folder that you have outside. So the folder containing all the project files. And here you can just, let's say, select the crawler environment, select one of the scenes and double click. So now it changes. As you can see now, the scene is made of the crawler scene. And it has all the crawlers that we were talking about here. So yeah, you can just figure out which one you'd like to see. And then for 3D ball, you can just select this one. So it's enabled in our environment, in our Unity scene. And let's check what is the agent. So the agent is mainly, it's a box collider. And then this is something that you add a component and then you add behavior parameters. So this C# class is part of the implementation of ML agents. So if you don't have ML agents, if you type here add component behavior parameters, you will not see it coming. So these are all the requirements, most of the requirements, let's say, that you need from the agent to report to the brain. So first of all, please assign a name to this behavior. So it's called 3D ball. And then you decide what is the vector observation. So if you remember here, that's why we talked about this part. You need to define what is the environment, what is the observation that you take to the agent. And then on the agent side, you decide which algorithm you will be using. And then inside again of the environment, you say what are the rewards, and then the action is taken inside of here. So you need also to define whenever you take an action, how to transform it into the environment. So let's say decompose these questions one by one. So first of all, what is the observations that the agent takes from the environment? Here, it says that there are 8 observations, okay? So let's open the file. Let's open the agent file, which is here. So as you can see here, yeah, I have just a problem here with C#, but I will open a new one. You have the 3D ball agent. So it's inheriting from the agent class. So the agent class is already provided by ML agents. And then you need to mainly, it's all about these 5 functions. So initialize, collect observation, on action received, on episode begin, and heuristic. So what are these things? First of all, initialize is asking you for the first time ever, whenever I initialize this environment, what are the things that I am supposed to do? And then on episode begin is like on each episode, when I start it, what are the things that I should do? And then collect observation, as we said, what are the observations that I will send to the brain of the agent? And then on action received, whenever I receive an action, how to transform it into something happening inside of the environment. And then heuristic is just an helper function, meaning that if we are not using a brain and you want to check something manually, so here you can say, okay, if I'm not connected to a brain or not learning as well, I will just use the keys horizontal and vertical here on the keyboard to play with the thing. So just if you want to debug something inside, you can use this way. So let's take it step by step. Initialize is just saying that, okay, I will, at the beginning, only on the first time ever, you have the, you get the rigid body of the ball because you needed to define where is the ball and how is interaction with the box or the cube. And then you reset all the parameters. So Academy is also a class of the, or namespace of the, of ML agents. And then you just reset all the environment parameters just to clean everything from the beginning. And then reset parameters is more or less set ball. So it's like setting the ball based on the mass and scale, like what we said earlier, like what kind of mass, what kind of scale that you want, based on what you're given from the beginning. Okay. So once we initialize, we do something that happens each time the episode restarts again. So here we say that whenever an episode restarts, we need to, this game object means the one that we are having now, which is the box. We need to adjust its rotation to be zeros. So it's not, so whenever you start this training or even this environment, you will always find the box in its right place, upright place. It will not be starting with an angle. And then you also give the quaternion, so it's the rotation. No, actually, it rotates. So here it gives it a random rotation, okay, between -10 and 10 in the X and Z direction. Bear in mind one thing if you're not familiar with Unity. So it has X and Z on the horizontal plane, and Y is the, let's say, the Z in Grasshopper. It might be a bit confusing sometimes. And then it adjusts the ball velocity to 0, 0, 0. So as you can see here, it starts at this point at 0, 0, 0, and then it falls down by gravity. That's why there's a gravity as a parameter. And then as you click start, it starts from 0, 0 and falls down on this cube, which is already tilting somehow. And then the position is also fixed. So in each environment, you will find it at the exact same position here. So we're talking per environment or per instance. So each time let's say the ball falls or whatever, and then you need to insert a new episode. And here we're talking local wise. So we're talking maybe this one fails, but the other one is working properly. So whenever one of these fails, we do the following. We do these ones and reset all the parameters. Okay, this is just a beginning, just to explain how to behave, how to restart everything once the episode finishes, whether by success or failure. And then now the most important thing is these two functions. So of course, these functions, they come like you just type them, and then they're empty, like they just, you need to deploy this thing by yourself. So here it says that this sensor, so collect observation is meaning that you collect what are the things that you want to get from the environment itself. So it's this part. So you have the environment, what are the things that you want to give to the agent? So here there is a vector, and this vector you add to it. So you add observation to this empty vector. The observations that we want to know is the Z rotation, so the rotation along the Z axis of the box, the rotation around the X axis of the box, and the position of the ball relative to the game object. And then the last one is the velocity of the ball, because clearly these are the most important things. This is what you sketch on paper. What are the things that I need to give to the agent to learn fast? So in here, maybe, by the way, you can come up with something that's different than this one, and it makes the learning easier. But for them, they realized, okay, the agent will not see anything but these observations, which is the rotation of the box, which makes sense, and in both directions. And then the position, relative position of the ball to the box, because of course, if the ball falls, you will have a big relative position, and then afterwards you will get a negative reward. So you will link that when the ball is too far, this means that I get a negative reward. So you will try to take actions. The agent will try to take actions that would prohibit or mitigate this high velocity. And then you have, or even if it has high velocity, so you need to, let's say the agent should take a quick position to reverse the direction or the rotation of the box. And the last thing is the ball velocity, which we said already. And then after you have the collect observation, you say, okay, what shall I do when I receive the actions? So normally the actions are received, they are considered, let's say, as whatever neural network, to simplify it. You give it the observation. So the observation are the inputs. Let's draw it in this way. So as if this is the brain. Of course, it's much more different than this one. But let's say this is the black box. Let's consider it for simplification only that this is like a deep neural network that's taking the input, which are the observations that we said. So the rotation of the box and whatever, and the velocity of the ball, and so on. And then it should cook something or decide on something based on a certain policy. And then it comes out with, here, it says 2 actions. So it will give you a value between 0 and 1, and another value between 0 and 1. Because you said that I just need 2 actions. What are these actions? So you take the action buffer, which is an output from the brain of the agent, and then you clamp it, means that you transform the values of 0 and 1 into -1 and 1 and multiply by 2. Same for the Z. And then they use them in here to determine the next rotation of Z and X. So eventually they're just numbers for the brain, but then using these inputs and outputs, the brain starts learning through the rewards. So if you have any, let's say, familiar with like neural networks and how, let's say, they learn. So eventually what you have as an output, you check, let's say in a supervised learning, you check, compare the value to the actual, let's say, parameters or the actual labels. And then the difference is what you update the weights of the neural network inside. Of course, this is like a clear abstraction of what's happening in reinforcement learning, and don't want you to get confused. But similar approach is happening here, that I'm learning, the agent is learning from the reward. So if it gets a negative reward, it understands that these values are not good when you have this kind of observation, so it tries to change it in the right direction. Okay, so this one is over. And I would just show you another example that we did in Digital Future workshop last July, and try also to train the agent. So let's just close this one. So here you have, let's say, again, an environment. So if you zoom out, we have 12 environments, and each one, it has only one goal. The goal is that you need to stack bricks as much as possible over each other. So in order to do so, our goal is to stack the bricks. We can also check, let's say, the agent quickly. Here's a bit complicated, but yeah, here we calculate some observations. like here what's happening is that we are calculating changing observation, because it depending on how much bricks you have inside of the environment. So maybe we can start like teaching it to see the process, so you can do it yourself on any project, and then we can explain this part. So what we will do here is that we have this thing already activated, and then in order to learn, in order to start learning, we need to say what will be the algorithm. So as we discussed before, if we have this thing, we need to define what will be the reinforcement learning algorithm that will define the policy and how to update the policy and so on, model-based, model-free, whatever. And then we define its hyperparameters. So the good thing about Unity, about ML agents, which you will have it in your folder here, is that it has, if you open, you will have something called config. So they are ready-made configurations for the environments that you had before. If we click on approximate policy optimization, PPO, you have, for example, the 3D wall is here. And these are, so it's just implementing PPO and it's telling you, please just update these parameters. So these parameters are like the hyperparameters of the PPO algorithm. You don't need to get inside of the algorithm. However, you need to understand what are these parameters. So I will send you the link. Feel free to ask about these ones as well. But we can check. I guess I have it in here. So this, let's say tab, is, let me send it to you. So in this tab, it explains how to train ML agents. So in order to train ML agents, you need to use the command ML agents learn to start training. And then you identify which configuration it should take. So here we will refer to the file, the YAML file that we have in here, whatever the name is. And then here you have also the name of the behavior. And these are all the hyperparameters. So if you go to this file, you will have an explanation of all the hyperparameters that are existing, depending on the kind of algorithm they're using, PPO or soft actor critic. So this is also a different kind of algorithm that they also have it ready for you, and you just need to change the hyperparameters based on what you have. So basically, I will go just quickly in this aspect. So normally the batch size and buffer size are like depending on how much complicated is your problem. So if the problem is complicated, or like you have too much steps to do for reaching a certain thing inside of the environment, you better increase this number somehow, of course, on the expense of the performance. And beta, I guess, is the you have the learning rate as any neural network, consider it as in this case. So of course, the more you increase it, it will learn quickly, but at the expense of quality of learning. So you don't know. So learning means jumping. So it jump in the, let's say, the optimization space quickly, quick steps. And then, of course, this is not a good thing if the problem is complicated, but also is a bad thing in terms of time. So if you reduce it too much, you will have a very slow training. So what you normally need to do they provide you in here with values. So here they're not providing. Yeah, here. So if you check, let's say training with PPO, you will find each parameter explaining what is this one. So for example, gamma is correspond to the discount factor for future rewards. So normally what you want to do is to have some sort of discounting factors that you want to win or to get as much rewards in the near future, which is, let's say, relatively more important depending on the kind of problem that you have, and then discounting the expected rewards later on. So they are still important, but not given the same significance. Of course, it's just a slight reduction in the value. So it's the typical range they're telling you is between 0.8 and 0.995, and so on. So it will take a lot of time to explain this. Also, time horizon is a really critical factor. Normalize, just an important, really important thing when it comes to neural networks in general, is that you need to unify the input. So if the input, the observation in our case is fluctuating, it has different numbers. So let's say velocities are between, I don't know, -50 and 50, depending on direction. Or let's say position is changing from 10 to 20. So if you have an input from 10 to 20, an input from -50 to 50, this will be a problematic in the neural network. So it's always advisable to normalize it. Let's say the best practice is to actually normalize it inside your code, and you don't need to use this anymore. So try to reparameterize or remap all your values between 0 and 1, or -1 and 1, let's say. Number of layers and hidden units are the number of layers of the neural network, let's say. And the hidden units, so is number of neurons per layer. So yeah, and these are other functions that we can also, if you have any questions and you know this stuff, we can discuss about it as well. So as you can see, now we have the problem. Okay, and now we want to train our agents based on what we give it in terms of observation and actions and so on. So first step we do is we check the right place. So the right place, let's assume that this is the right place because we actually downloaded this function. And what we need to do actually is to, let's go to this place, see this, DigitalFUTURES. Okay, ML agents. And we have config, PPO. So I will just, to make it easier, I will use the worm. The worm, let's say, environment was a little bit more sophisticated than the 3D ball. You can see it from the batch size and buffer size. There is a significant difference here. The number are increasing because it's a pretty complex project. And what we will do is that, let's say, okay, I will use this one. I'll just copy it and new owner, which is whatever name you want to name it. And then I will put it here, and then I will rename it something I had it before. Okay, so I just renamed the file, the YAML file that I will use it for the training of the PPO algorithm. One more thing you might notice here is the name of the behavior, which is super important. Sometimes it's create you problems, of course, is that the behavior name is worm, but here in our environment, the behavior name is stacker. So I need to change the behavior name here into stacker to be able to work properly, save it. And then I will just refer in the command line here to this place. So we can open this file. We close this one first. Open this file. And then we can get this directory. Then we go here, we say, so now it's in this place, and now it's ready to say to refer to this file for the learning process. So how to do this? As you remember here, we had the explanation. So in order to start learning, you need to use the command ML agents learn, and then with the configuration, name of the configuration file, which is trials from worm. So I already got this prepared, but on another directory, so we can just take this one, trial from worm.tml, and then you give it a run ID. Run ID means just because you do a lot of runs, like a lot of trials. So you just make it significant to see the results afterwards. And then, so hence you do this. You use force if you, let's say, have this ID already there and you want to force new results in it. So as if it's like remove all the previous results and force a new one. You can use resume whenever you stop the training and you want to resume again. And without anything, if you want it for the first time and there is no in the folder any ID of this one. And then you come here, you go write this one, enter. Whenever you see this tab, okay, this means that everything is going well. And then it will ask you that it's already listening to the port. So once it's listening, you say, okay, please start training. So as you can see here, now it's training, it's trying, starts of course in a bad way. It's not so good. It's not trying to stack the bricks over each other. It's doing a random behavior. The same for all the other, let's say, instances. But maybe during our Q&A, we can see the improvement in such a small amount of time here. So as you can see, it gives you the hyperparameters that were already mentioned in the YAML file. So just to make sure that these are adjusted correctly. And then afterwards, after a couple of minutes, it starts to update like how many, depending on how much you tell it, like after, let's say, 1,000 steps, please tell me a summary of what's happening. So now it's every 30,000 step, it gets the amount of seconds it takes to update the mean reward that we have, which is 0.29, which is a good indication when you see like the progress. So if the reward is remaining more or less the same or getting even worse, so you just realize that, okay, there's something wrong, and then you go and debug it. So let's keep this one here. And yeah, I guess it's almost 6. So if you guys, we can make the Q&A now, and then we can, after in the end, check how it got better. So thank you guys. And I've been talking a lot, so please, you're welcome for any questions. Thank you.
Yeah, thank you. Thank you, Ahmed, for the session. I think while students are still looking at asking some questions, or maybe I'm assuming that they will follow along the tutorial that will be uploaded on our YouTube archive. And maybe they will have questions to reach out to you. So, we already have a question from Naseem. I don't know if you would like to ask your question, Naseem, or should we ask it for you? Okay, I'll just go ahead. So what Naseem is asking is, instead of C#, could we write the section by Python?
So since most of the libraries are applied in Python, this is one thing. That's why ML Agents is giving like this thing on the background. But in Unity, in order to develop any classes, you write in C#. So as long as you want to use in Unity, you apply this kind of transformation or giving information through C#. And then ML Agents does the job of transforming this input and output into the Python code is implementing depending on the algorithm you're using, and then goes back getting the data and then providing to you in Unity. So it's doing this for you. But let's say if you're using another platform, if you're using Colab directly to build your own, let's say, environment inside of it or something. So this is let's say, I would say, an advanced way if you want to do it. But this one, if you're familiar with things in Unity, it makes it easier for you and provide more, let's say, robust way of exchange.
Mm-hmm. I hope that kind of gave you some things to talk about, Naseem. I believe I have just a couple of basic questions also for the audience who might be starting up now with these platforms, Unity, and working with Anaconda as well. So, Ahmed, if you have any suggestion for good platforms, YouTube channels, or other learning channels or platforms which students can refer to, it will be good if you could highlight a little bit on that. And my second part of the same question is that what is the best workflow which you have over the years worked with for working in, especially in the advanced AEC sector, for architects and designers to use machine learning while working in the design workflows as well?
Okay, so for the first question, if we're still, let's say, within the area of this tutorial, for Anaconda, I would not, let's say, I don't have any, let's say, specific videos to work on, because Anaconda itself is just an enabler of what you're doing. So let's say I wouldn't know about Anaconda if I did not use ML agents or did not use something in Grasshopper that requires an environment. So it depends on your final goal, and then eventually you realize, okay, I need Anaconda in this way. And then when you search for this main topic, you will find people explaining how to, let's say, install things on Anaconda. But I would not recommend spending too much time on it, because it's just an enabler. It's just as if, like, instead of using Windows, you're using Linux. So it gets a bit difficult in the beginning, but just you can easily find a way based on what you're looking for in the final end. Regarding AEC, it depends on what you have. So I mean, also these days you can see a lot of so basically, I would say in the architecture part, there's always this integration of Grasshopper too much. So familiarity with Grasshopper, and there are a lot of, let's say, interfaces now that are working to enable machine learning inside of Grasshopper, even with the ChatGPT and everything. So you just find some kind of integration, do your own machine learning outside, and then get the results inside of Grasshopper. My personal belief, and this is something I would just clearly that it's my opinion that Grasshopper is really nice for prototypes, but once things get a bit complicated, it's so hard to deploy. It's so easy for prototypes, that's why we love it. But I would say there is a big potential for game engines. So independent is not only Unity or Unreal Engine or whatever, but it's the place where there could be a real potential to combine or to find the construction constraints or problems inside the simulated environment. So you can, prior to your design, you can check if this will work or not. And this is really important, because what happens now is the segregation in our industry. So you find the design, it looks extremely nice, but then you end up, even during fabrication, with a lot of problems. So I believe this kind of simulation environments would be nice. And one last thing regarding places, there is also a really good example of, it's not related to AC, but a good example of environment in Unity for ML agents. It's called Hummingbirds. It's already on Unity Learn, so I can also share the link, so you can you find someone who's going through all the details, all the functions, and so on.
Mm-hmm. Yeah, I think This sounds helpful, and I think what you're saying also makes sense as you go along and work with what your end goal for the project is. A lot of plugins and a lot of platforms might come in handy. Uh, just another thing, Ahmed, in case students want to reach out to you while they are working, same for our YouTube audience as well. Is there any way they can connect with you over Discord or maybe your email that you'd like to share?
Yeah, for sure. I can leave also my email if anybody wants to reach out.
Mhm. Yeah, that's good. Um,
Yeah. Yeah, also, Ahmed, I really want to thank you. I think it was a really great mix between those guided levels of instruction, as well as I think you really opened doors to like future topics. And one of the topics that I also had in mind at the beginning of the session you touched on is ChatGPT. And I want to kind of reflect or know more on your thoughts on how does this self-learning bots, how can we learn from them, or what can we use from ChatGPT to help us develop our agent training process? So just your general thoughts on it.
Uh, Thanks, Shim, for your nice words, and I would say we are going, like, especially with ChatGPT and its let's say similar architecture, that it's kind of helping you to identify the generic workflow. So you still need to have an understanding more or less of what will be happening, but then it can give you a generic overview, and then when you know exactly what you can achieve, so a certain snippet of code or anything, it could directly give it to you. So I would say reliability 100% on the machine is not possible yet. You still need to have some knowledge to say, okay, this code has some flaws, or I will try to readjust it in a way to help us in this manner. And second question might be an indirect answer, but the way some of the algorithms that would, let's say, give the agent the possibility, or like give the machine the possibility to explore different routes or different situations. I think it's an interesting path, especially in our industry, because let's say if you try to simulate as much as possible a task, a generic task, and you find the proper, let's say, vocabulary to define this task, you would still be amazed by how the agent can reach some steps that are hard to be achieved by the normal person. Even it would take more time or whatever, like a training. And then the robust thing is its ability to use this knowledge in a different domain or in a different situation. So let's say this is where the hype of all research is going on. So how to provide eventually the code that does anything, or like the algorithm that solves anything. Just practically impossible, but I guess it's a good direction to go to. So how to generalize algorithms as much as possible to solve as much problems as possible. And with this direction, you found GPT, which is something, whatever the question you're asking is trying to provide an answer to, which is, for me, is pretty interesting. I hope I answered the question in what you intended to hear.
Yes, absolutely. I think it's a really rapidly growing platform. Have you tried incorporating it in your workflow as well?
So normally, coding wise, and also like we had let's say some kind of problems. I was also asking, like, please find me the best way to simulate clay, for example, or so this kind of generic questions. Actually, there were some problems because it was giving me links to videos to learn from, and all of them were not working because it was it's learning till 2021. So anything afterwards is not included. So all the links were obsolete. But at the same time, if you ask it like a generic how to do this thing, it would give you a rough explanation. But then if you dig deeper, of course, there are still a lot of problems. Like for example, it was telling me on Unity that you could use, let's say, not rigid body, but like soft body. And then I was telling her like there's no soft body in Unity. Then he or she is a debate. It was telling me that, yeah, you're right, it's not there. But maybe you can buy a plugin or something on Unity. So I mean, it's like a person who's not 100% making the right decisions, but at least helping you with some information. So a little bit of less trust. So not 100% trust in it, but like try to be skeptical with the output that it's providing.
Absolutely agree. I felt the same way using it.
You encountered the same problem as well?
Yeah, because it did not, even when I tried to regenerate responses, it would not give you a direct one. It would just reiterate just the old response. So I don't get the up-to-date versions of everything. So I understand that.
It will soon be updated. So I mean, yeah, things are working really fast in this sector, but still in our industry, nothing is happening so far. So yeah. Just
Do we have any more questions?
No, we don't have any questions, but I'm sure people will reach out to you. Ahmed, students will reach out to you with lots of questions. I don't know, Ahmed, if you have anything final from your tutorial to kind of talk about, or should we just stop the screen share?
Yeah, I will just say something quick that as you can see here, this was the learning process. It started with a mean reward of 0.29, and then now it got a mean reward of 0.9, and the maximum that it could get is 1. So maybe it's not perfect, but as you can see, it's trying more or less to put the, it's a bit hard to move with that. So it's trying more or less to put the bricks over each other now without falling. So, I mean, in a simple example as this one, you can quickly notice that there is the progress and if the algorithm is working properly or not. So this is an important thing to keep an eye on. Also the type of reward that you're providing, because maybe it's learning something, but is not what you want to achieve. And eventually I would just say it's a pretty, let's say, big topic. And it's really interesting. It's hard to wrap in 2 hours, but I'm really glad that there is this kind of tutorials and opportunities to just ring a bell or open a door for this kind of things.
All right. Thank you very much, Ahmed, for such a rich tutorial. Again, I'm pretty sure students will come back to this with even more questions during the process. And I want to thank everyone who joined us today, both on Zoom and live stream. And I will take the opportunity to also announce to you our upcoming sessions and tutorials. So for our next tutorials in our Saturday series include Grasshopper Basics tutorial, which is happening next month, and a KUKA PRC in March. And you'll have lots of more information. Just stay tuned on our social media platforms on Instagram, YouTube, and on Discord. Thank you, everyone, for joining us today.
Thank you for everything.
Ahmed.
Thanks a lot. Thank you, and see you all guys soon. Thank you.
Yeah.
Have a nice weekend.
Yes.
Thank you, guys.
Bye.